Good evening everybody and welcome to the vlog for Thursday, June 29th, 2017. I hope this video finds you well. As I mentioned last week, today is my only work day for game development, as I just got back from a very relaxing vacation weekend. And like I said, I did have a bunch of time and some car rides to think some things over and start working some cool things out. So I got a lot of really cool stuff in the pipeline, and one of those being the topic of the show today. So I had a very productive day today. I began designing and programming my procedural generation system. As I've kind of hinted at before, my game is going to have procedurally generated levels. And again, this means that the levels are created by the computer, so each time a player plays your game, they're going to have a slightly different experience. And so I'm going to give you guys a little peek behind the curtain of how exactly my procedural generation is going to work, at least as of right now. So there are three major steps to my procedural generation algorithm. The first step is to create a grid. It's just a simple two-dimensional array. The next step is to randomly select a starting point from the top row and an ending point from the bottom row. And then the computer creates a main path from the starting point to the ending point. And then the final step is to actually make this path a little more interesting by turning each section of the path into different rooms. So essentially, if one tile has an entrance on the top and an exit on the bottom, it'll just make a straight line through. As you see in some other tiles where there's a top entrance and a bottom exit, the path is a little curvy or it bubbles out. And then same thing with turns. Some are a little more straightforward and some kind of have some more open area for conflict to occur. And then you'll also notice some rooms that I've highlighted in green that are off of the main path. Now these will still be accessible to the player at the cost of some resources, but will often provide greater rewards than sticking to the main path. So today I was able to complete the first two steps, which were creating the grid and finding a path between the entrance and exit points. So I came up with this algorithm today, and I'd just like to briefly go over some of the pseudocode for it so you can understand how exactly it works if you're interested. So this might look a little bit confusing to some of you, but it's actually pretty simple. And for this code, I have a custom struct and a class. The struct is basically a vector2 but for integers. And so this is basically just one variable that holds an x and a y coordinate. Simple. And I gave it some operators to tell if two of these variables are equal to each other, not equal to each other, and a way that I can add them together. I also created a class for the tiles. The tiles contain a game object for the room, a Boolean variable to check whether it is or is not on the main path, and an integer vector2 structure for the XY coordinates of that tile. So we'll start right here. We'll make a new list of tiles called main path, and we'll call our create grid function. The create grid function has no return type, and it starts off by creating a two-dimensional array of tiles. So again, that's just this set of tiles right here, and it can be any size that you want, but for right now, this is just a 4x4 grid. Next, this will randomly choose a starting point along the top of the grid and an ending point along the bottom. This then calls the find path function. Now, the find path function is a recursive function, meaning that this function calls itself over and over and over again until a base case is reached. So this find path function takes in an integer vector2 struct for the current position and end position. Again, these are just the XY coordinates of the current position and end position. So when we first call the function, this will be between the starting position and the ending position. And I forgot something that I kind of squeeze in on the side here. This basically just sets the current node's isOnPath variable to true. Now, one of the first things you want to do in a recursive function is check to see if the base case has been reached yet. In this case, the base case has been reached when the current position is the same as the end position, meaning that we have reached the end of the path. In this case, the function just returns true. Next, we'll create a list of available tiles. This for loop basically just goes to the adjacent tiles up, down, left, and right to the current tile. And this calls a function which I've called check availability, and all it does is it checks for two things. It checks to make sure it's actually on the grid. So for example, if we were starting on this tile right here, it's going to check to see if there's a tile up above it, and there's not. So in that case it would return false. And the other thing it checks for is if the adjacent tile has already been on the path. So if we were on this tile and we wanted to look back at this tile, we might see that this tile is already on the path. So that'll return false. And so with that, we'll have a list of available nodes. And so again, an available node is a tile that is on the grid but is not on the main path yet. So now we go to a while loop and we just say, while the number of available nodes is greater than 0, perform these steps. So basically, while we have an available node to choose from, choose a random node from the list of available nodes, and then call the findPath function using that new available node and the endpoint. So it loops up to the top here, checks for the base case, checks nodes adjacent to that, goes through this while loop again, and loops through that until it hits the endpoint. Now the reason we have a while loop here is because we might be drawing out a path and get to a spot where there's no potential other moves to go. And so in this case, the function returns false and it goes back to the previous node. It will delete that node as an available tile because that solution didn't work. And it will pick another tile from the list of remaining available tiles. And then eventually the base case will be reached in which the current tile is the end tile. And then all the recursive functions will return true. And it basically snakes the path backwards from the end tile to the beginning tile and keeps track of each of these tiles along the way. And now we'll come back up to the create grid function, and all we need to do is reverse that main path list. So the start node is at the beginning and the end node is at the end. Now, real quickly, I'd just like to show you how this works out on paper for all you visual learners out there. So we'll start by randomly choosing a starting point and an ending point. So a starting point along the top is here, and our starting point along the bottom is right here. Now we'll start at this tile and we'll see what tiles are available for us to move on. So it'll check above, and that's not a tile, so we can't move there. We'll check to the side, that is an available tile. Below us is an available tile, and to the other side is also an available tile. So the computer will randomly choose one of these 3 available tiles to go to next. And we'll say it goes down to this tile. Now again, this checks the surrounding tiles to see if any of them are available tiles. And in this case, this one, and this one are all available tiles. So we'll say the program chooses this one. Now, here the available tiles are here and here. So what happens if the program chooses this tile? Well, then this will check for available tiles. It'll see here, 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 and here. And it has no possible available tiles. So the findPath function for this particular instance returns false, and we're back to this tile. This tile has now been removed from this list of available tiles, and the only place to go is this tile. And that continues on until the end tile is reached. So that's basically what I have right now for my path finding algorithm. It seems to work pretty well right now, but there are a couple little bugs I need to work out, of course. And I took some video footage of what it looks like in the engine. It's pretty simple right now. It just makes a bunch of boxes. It has a green box for the starting point, a red box for the end point, and then a bunch of blue boxes for the main path. And then each box is numbered from 0 to whatever, and then you can follow the path of incrementing numbers to find your way from the beginning to the end. And so that's basically what I did today. I'm super stoked that I got that going. This whole task of making my game procedurally generated has seemed pretty daunting, and I'm finally glad that I got to start chipping away at it just a little bit. And with that, I hope you all have a great rest of your day. Please like this video if you found it useful. If you just found my channel for the first time, please hit that subscribe button so you can get a lot more content just like this. And if you have any questions on any of this, feel free to leave me some comments in the comment section below. Hope you have a great rest of your day, everyone.